The short seeker module, it's intended to find shorted components on boards. It's based on the principle of a milliohm meter. It uses Kelvin probes, simple Kelvin probes with signal and sense, so to eliminate the wires out of the equation. Let's turn it on. There's a menu with instructions. It's audio visual, means I have a visual part, audio part. It's not intended as an exact milliohm meter. It's more to see trends. As you see, we have a LED bar here, which is now in the middle. I'm using a potentiometer to simulate a short. And you see if it increases, goes to the left, decreases, go to the right. I also have an audio part in here. The closer I get to the short, the higher the pitch. And the other way around, of course. If I'm getting very close to the short, I can retune it by pressing this one. So it's back at the default setting. I can go further. So every time I can just tune it. So volume and mute. This is manual mode. I can also do the same in automatic mode. In the automatic mode, it will calibrate itself. And if I go outside of the window and have a stable measurement, it will recalibrate itself back again, and so on. So no need for a manual intervention. You could manually reset it, but there's no need to do that. So I reached the limit there. So the other way around as well. So it recalibrates this value to the center value. I can set the range. I have 3 ranges or 4 ranges: 0.0 ohm, 2 ohm, 20 ohm, and 200 ohms. I can also set the sensitivity. I can make it way more sensitive, which means a very little variation. There's an immediate change in tone. And calibrating again. So sensitivity is actually the window that it uses. So one more setting. I can, oh, wrong one. Let's power up again. I put it accidentally to sleep. That's not my intention. I'll show the LED bar. So instead of one LED, I have a bar here. Same principle. So the concept, well, the display concept, all of the concept is loosely based on the EDS89, but the electronics is completely different. I work with a very low voltage, maximum 0.3 volts, or 300 millivolts. In one of the ranges is 30 millivolts, in the other range 50 millivolts, so it's very sensitive. So that's basically the short seeker. That's it. Let's have a look at the short seeker module. In the front, the display, 2 to 3 encoders, 4 connections to the test probe. So we use a Kelvin probe, we have a signal, and we have a sense, and a speaker, of course. ESP32, power connector, the speaker part, amplifier up here, TDA 2822, master volume can be calibrated. The audio is generated by the CPU, DAC port is used for that, wires to the speaker, some relays, relay driver up here, ULN 2003. It's a system with a current source up here, so I can set different levels of current. An amplifier which measures the sense. It's a chopper stabilized amplifier. I can set the gain from the amplifier as well. The special thing about this circuit is that the voltage over the test object is very limited. There's a limiting circuit up here. It will measure the output of the op-amp, and if it's above 0.3 volts, it will dissipate a bit of the current, so it will remove voltage away from the test points. And if the amplifier is set to a higher gain than 1, it can be set to 1, to 10 and 20, I believe. When it's set to 1, then it's 0.3 volt. When it's set to 10, for example, then there's only 1/10 of it is 30 millivolts instead of 300 millivolts. And set to 20, it lowers to 50 millivolts. So the test voltage is very low. So we basically have a millivoltmeter here, or as you wish, with the current source, a milliohm meter. Some quad op-amp here for level conditioning. And we use a 16-bit analog to digital converter with the I2C bus. And that's about the circuit. So we actually measure very low ohms and then convert it to a measurement and a tone.